Alright, so in this video, I'm going to solve the equation x to the power of 12 minus 1 is equal to 0. So to solve this, I'm going to first rewrite this as x to the power of 6 to the power of 2 minus 1 squared is equal to 0. And the reason I'm doing this is so I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into x to the power of 6 plus 1 times x to the power of 6 minus 1 is equal to 0. So this gives me two equations. I get x to the power of 6 plus 1 equals 0, and x to the power of 6 minus 1 equals 0. Now I'm going to do the same thing again. I'm going to rewrite x to the power of 6 minus 1 equals 0 as x to the power of 3 to the power of 2 minus 1 squared is equal to 0. So I can use this property again and get x to the power of 3 plus 1 times x to the power of 3 minus 1 is equal to 0. Now, for x to the power of 3 minus 1 equals 0, I'm going to rewrite this as x to the power of 3 minus 1 to the power of 3 equals 0, so I can use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So this turns into a minus b times a squared plus a plus 1 is equal to 0. Sorry, this turns into x minus 1 times x squared plus x plus 1 is equal to 0, which gives me yet another two equations. So now I have x minus 1 equals 0 and x squared plus x plus 1 equals 0. So for x minus 1 equals 0, all I have to do is add 1 on both sides, and I get x is equal to 1. And for x squared plus x plus 1 equals 0, I can use the quadratic formula. So by using it, I get x is equal to negative 1 plus or minus the square root of 3i over 2. So these are two more solutions. And now we aren't done yet because we also have to solve these. So now I have x to the power of 3 plus 1 is equal to 0. And I'm going to subtract 1 on both sides, so I get x to the power of 3 is equal to negative 1, meaning x is also equal to negative 1. So this is another solution. Now for x to the power of 6 plus 1 equals 0, I'm going to again subtract 1 on both sides. So I get x to the power of 6 is equal to negative 1. And if I take the 6th root, I get x is equal to 6th root of negative 1, which is equal to negative 1 to the power of 1 over 6. So now, the 6th root of negative 1 is, we know that I is equal to the square root of negative 1, which is equal to negative 1 to the power of 1/2. So negative 1 to the power of 1 over 6 is the same thing as negative 1 to the power of 1/2 minus something. So now 1 over 6, or I should say 1/2 minus 1 over 6 is equal to 1 over 3. So 1 over 6 plus 1 over 3 is equal to 1/2. We know this. Meaning we have negative 1 to the power of 1 over 6 and this plus, or sorry, 1 over 2 minus 1 over 3 is what we can rewrite 1 over 6 as. Now, this is the same thing as 1/2 plus negative 1 over 3. And if I have something in the form a to the power of m plus n, This is equal to a to the power of m times a to the power of n. So this is going to equal negative 1 to the power of 1/2 times negative 1 to the power of negative 1 over 3. Negative 1 to the power of 1/2 is the square root of negative 1, which is equal to I. So we get I times negative 1 to the power of negative 1 over 3, which is the same thing as 1 over negative 1 to the power of 1 over 3, which is equal to negative 1. So I get I times negative 1, which is equal to negative I, which is my final solution. Alright, so for this video, I'm going to solve the equation 3 to the power of x to the power of 2 over 9 to the power of x is equal to 81. So to solve this, I want all my terms in the same base. And in this case, this would be a base of 3 because all of these are powers of 3. So we don't need to change 3 to the power of x squared because this is already a base of 3. But 9, I'm going to change to 3 squared, so I get 3 squared to the power of x. And 81, I'm going to change to 3 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So I get 3 to the power of x squared over 3 to the power of 2x is equal to 3 to the power of 4. And now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So I get 3 to the power of x squared minus 2x is equal to 3 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means m is equal to n. So this means x squared minus 2x is equal to 4. Now if I subtract both sides by 4, I get x squared minus 2x minus 4 is equal to 0. Now to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 2, and c is negative 4. So I get x is equal to negative of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 4 all over 2 times 1. Now from here, I get x is equal to 2 plus or minus the square root of 4 plus 16 over 2. So I'm going to rewrite that over here. X is equal to 2 plus or minus the square root of 20 over 2. Now, the square root of 20 is the same thing as the square root of 5 times 4, which is equal to the square root of 5 times the square root of 4, which is equal to 2 root 5. So I get x is equal to 2 plus or minus 2 root 5 over 2, meaning x is equal to 1 plus or minus the square root of 5. So these are my two solutions to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and also share this video to your friends or family because that would support a lot. And if you want to watch more videos like these, check out my channel because I have a bunch of challenge problems such as these ones. Thank you.